Okay, hello students. Last time we have seen the definition of what is the meaning of 1 radian, and we have seen for a unit circle. So if this is 1 unit, and if the arc of whatever the radius 1 unit, if the arc length of the arc, if it is equal to the radius of this one, then we say, hey, that's 1 radian. And we also have seen that the whole around is 2 pi, and we saw that 2 pi, which is 2 pi radians, is same as 360 degrees. And then we try to fill this chart also. So how to remember 360 degrees, 180, 90, 60, 30, 45, and 270. Today what I wanted to show is the target of objective of this video is for you guys to know what is the meaning of angles in the standard position and the length of the arc, area of a circular motion. So I'll go with the first one, angle. So before I dive down to what is the angle in standard position, make sure, let's see, if what I try to do is to show in degrees. This, the top line is in degrees and this is in radians, because 0 to 360 is same as 0 to 2 pi. So what I'm going to do, I'm going to wrap around this whole line, this line, the circumference. Remember, this is the circumference of the circle, which is 2 pi, right? So I can go wrap around, starting this point right here, and we can wrap this around. And when I wrap around, this 90 will go right here, so that's 90 degrees, then 180 degrees, then 270 is right here, and then you're back to this is 0 degrees as well as 360 degrees. So when I'm wrapping around this circumference, so where are those 30? Let's fill this out, all of them. So this will be this is 90, 180, 270. So where is angle 30? So this 360 is also 2 pi, 90 is pi by 2, 180 is pi, 270 is 3 pi by 2. Now I'm going to split 90 as, we can write 90 as 30 plus 30 plus 30, right? So we can break this into 3 pieces here. See, each of those 90 degrees I can split into 3, so that this 30 will move here. So this is 30 degrees, and right, and it will reflect over the origin, so there will be another angle right here. So this is 30 degrees. This is 180, and 180 plus 30 will be 210 degrees. And this is 60 degrees. So from here I can draw. So all around this is 60 degrees. So this part until here is 270. So I can reduce this by 1, or you can add 30 to 210, becomes 240 degrees. And the same thing I will do right here. So this will be 90 plus 30 will be 120 degrees. And this side, 270 plus 30 will be 300 degrees. And the last one I can do is so 120 plus 30 will give 150 degrees, and this is 300 plus 30, this will be 330. Okay. So let's understand each of those angles. So this one is pi by 6 because see last time I explained how do you get, if it is 3 you just put it 6 in the, you can remember because pi will be always there and 6 complements 3. If it is 6 here, this will be pi by 3. This is already pi by 2. So I can count now and say, hey, let me use the black color. Okay, so this is 1 pi by 6. This is 2 pi by 6. Remember, there are 2. This is 2 pi by 6. But 2 pi by 6, 2 cancels with 3 and you get that. So we don't have to write. So this is pi by, so 1 pi by 6, 2 pi by 6. This is 3 pi by 6, which is pi by 2. This is 4 pi by 6. So if it is 4 pi by 6, we can still reduce this and write it as 2 pi by 3. And remember, this is a reflection of this point. And what about, so 1 pi by 6, 2 pi by 6, 3 pi 4, and this is 5. This point will be 5. So 150 is 5 pi by 6. This is 6 pi by 6, and which is pi. This will be 7 pi by 6. This will be 8 pi by 6. And we can reduce this and write it as 2 divides 8 and 6, which is 2 pi by 3. So I'm going to use that 2 pi by 6, and then this is, so again I repeat, 1 pi by 6, 2, 3, 4, 5, 6, 7, 8, and this is 9 pi by 6, and this is 9 pi by 6 is 3 pi by 2. 10 pi by 6, so this is 10 pi by 6. Now what is 10 pi by 6? So 2 divides this and become 5 pi by 3. So 560, so remember this means it is 5/60. And the last one is, this will be 11 pi by 6. You can clearly see. So what are we supposed to know is, okay, so this is pi by 6. So here, this is all multiples of 30 degrees, which is pi by 6, so we can remember this way. One more thing is we forgot is, where is 45 degrees? So 45 degrees is here, I'm going to draw a dotted line. So this is 45 degrees, which is pi by 4. And same thing I can go all the way, which is a reflection of that point. So this will be, now this is 45, so there are two 45s. So pi by 4, two of this pi by 4 fits in 90 degrees, which is pi by 2. So 1 pi by 4, 2 pi by 4, 3 pi by 4. So here in between there will be, here between this one. So there will be, this is 3 pi by 4, which is 135. So let me write this is, so this is 135 degrees, which is 3 pi by 4. So this point, angle. So 135 is because 45 plus, so we have 3 45s. So this until here is one of them, then another one for 45, then another 45, all together makes it 45, 45, 45 is 135, which is 3 pi by 4, because this 145, one of the 45 is pi by 4. Then this will be 4 pi by 4, and then again there is 5 pi by 4. So let me write 5 pi by 4. It means 180 plus 45 will give you 225 degrees here. This will be 6 pi by 4, then comes 7 pi by 4. And 7 pi by 4 is, let me write this as 315 degrees, which is 7 pi by 4. So hope this makes sense. Just to get a whole idea, the entire unit circle is, I try to write all different angles in degrees. So you wrap this around, and then you try to see which places what angle is. And the main thing is 30, 60, 45 and its multiples. Hope this helps. Now I'm gonna go directly to understand what is the length of the arc. So let's go. So how do we find length of, oh, before that I forgot what is the meaning of angles in standard position. So if this is the, so let me take this off everything. Oh, I'm gonna use, so what is angle in standard position? So if you have a circle at the center, which is aligned along with this, the x-axis and the y-axis, okay, and if there is an angle, so suppose there's an angle right here, this is the angle, and AOB. So this angle we say is in a standard position if the vertex is placed right here, and this is the initial side and the terminal side. So the initial side has to align along with the x-axis. So this will be B. And the terminal side will be somewhere here. So an angle of such angle when the initial side is aligned on the positive direction of the x-axis, and then depending on how much is the angle, the A will lie on the circle. So this angle AOB is this angle AOB now is in standard position. Now, question is, if this is one angle, and I just assume that let's see this is a 60-degree angle. Question is, what is the meaning of next definition is coterminal angle. So what are coterminal angles? So if this is 60 degrees, one of the angle in the standard position. So if I rotate this OA, so if I rotate this, see this part, so this is the one. So the OB, the angle is formed when this moves, see, until OA, that's the angle 60. Then is there another angle we can think of? So I can go all around one more this way and come back to the same position, see? So it means it is 60, so this is already 60, but if you're going around, all around is 360, which is also 2 pi, so that, and then you come back to here, that means it's 60 plus 360, and you get an angle called coterminal. So this is the original angle, and now you move this way and come back. So this is 60 plus 360. And such angles, again AOB, is called by defined as coterminal angles. So the question is this the only angle that we can have? So we can have another one. So not just, so if 60 is one of the angle, then the coterminal will be 60 plus 360. I can do one more time this way and becomes 60 plus 3 twice. So this is 1 times 360. So this is 1 times 360, 2 times 360, and likewise we can say if there is an angle theta in degrees, then it will be theta. If theta is the angle, right now I give 60, so this will be k times 360 degrees. Oh, sorry, it will be two times. Sorry, k times could be positive, negative. What I'm saying is, let's say this is in the counterclockwise direction. Let me use another angle in the clockwise direction. So is there another angle in the clockwise direction? Now if this is 60, we can rotate this OB, I can go clockwise direction 90 plus 90 plus another 90, and then there is some angle here, right? So if this is 60, by default, because this is 90, this will be 30 degrees. So it is 90 plus 90 plus 90, which is 270 plus 30. So that means this will be minus 270 plus 30 is 300 degrees. So not just this one, it is also clockwise, but this time what's happening is the answer is minus 330, but we can also just write 60 minus 360 degrees is minus 330 degrees. Or you can also do twice times 360, which will be, you can work this out, 60 minus 720 and get the answer. So the goal is, if it is theta, so you can write minus 2 times 360, and you kind of get a formula, this is the formula, where k takes the value, positive and negative integers, so we just say integers. And we say, yeah, so any multiple of k, integer multiple of 360, or if it is in radians, so suppose this was given in pi by 3, so this is pi by 3, because 60 is pi by 3. We can also use the same formula, but this time it will be theta plus k times 2 pi, because 2 pi is 360 degrees, so it is pi theta plus k. So these are coterminal angles, coterminal angles to whatever the angle given theta. So hope that helps. The goal is to understand that how do we get this and this, and you can use for any angles. I just showed you for an example for 60. You could do it for let's see, there was an angle. So if the angle was given pi by 3, pi by 6, let's say this was pi by 6, 60 degrees, 30 degrees, so this is pi by 6. Then what are the coterminal angles for this one? So this is theta, right? So you just write pi by 6, so 2 positive, if the question is asked 2 positive coterminal angle, so it will be pi by 6 plus 1 pi, so k pi, you can just put 2 pi, and the second one you can think of is plus 2 times 2 pi. So that means you're using, instead of k, you are writing 1, and instead of k, you are using 2. Okay, so positive, so because this is 6, I will multiply 6 divided by 6, so this will be 12, this whole thing will be 12 pi, and there's 1 pi, so the answer becomes 13 pi by 6. In this case, again I multiply 6 times 6, so 4 times 6 will be 36, this will be 37 pi by 6. But if the question was asked negative angles, so 2 positive angles, and here I'm writing 2 negative angles, then we have to write pi by 6 minus 1 pi by 6. That's how you 2 pi minus 2 pi, and the second one is pi by 6 minus 2 times 2 pi. So this you multiply 6, 12, you get minus 11 pi by 6, and in this case multiply 6 and divide by 6. So from 36, if you work this out, do your maths, and you will see, I think it's minus 35 by 6 pi. So these are the questions are being asked for SAT, ACT. Like you have to know which are the 2 positive and which are the 2 negative angles. The last part is about length of the arc. So how do we find before I just show that, just remember that how many pi by 6 feet in a circle? And the second is how many pi by 3 feet in a circle? And how many 45? So this is another important pi by 4. How many 45 feet? So if you have a circle, see this part, we can split this into, if it is pi by 6 is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and we are back to 360. So how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of this. So 12 of these fit in the, because we need in the later class that at the tip of the tongue, if I ask you what is cosecant of, let's see, 15 pi by or 17 pi by 6, and we need to know such cases by just knowing, hey, 12 of them make pi by 6, 12 pi by 6 make the whole round. So if it is 12, this is same as, you take away 12 here, you get 5, from 12 to 7 is 5 pi by 6, so easy. So that's how we are going to do that, to check on how many pi by 6 fit in a circle, and in this case, how many fit here. Pi by 3 means 60 degrees, so 60 degree will be here, one of them, another 60 will be 30 plus 30, another here, this will be another 60, so 60, 60, 60, I made a mistake here, this is wrong, this is 60, then from here to here another 60, and then another 60, another 60, another 60 here, let me take this off, I don't want to get confused here, 60 and 60, and you can clearly see, if I divide 360 by 60, you do get 6, right? So 6 of those 60 is pi, so what is this pi by 3? So 1 pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3, and 6 pi by 3. So there are 6 pi by 3s that fit in a circle. And the last one is 45. So we have 145, 245, 345, 445, 545, 645, 7, and 8. So there are 8 45s. That means 8 pi by 4s. So that means this is pi by 4, another pi by 4, another pi by 4, another pi by 4. So likewise, there are 8 pi by 4s. So anytime question could be asked, what is 21 pi by 4? So we need to know that in the later class. And finally, I would like to show the length of the arc. So let this be a circle. Let it be a circle of radius r, and we need to know what is the, if there is an arc, let's say this is the arc, and we want to know what is the distance. So s represents the length of the arc, and this makes an angle. We don't know what is that angle, I'll call it theta. So we want to know, now that theta by definition, remember, we want to know how many of this radii from here to here, how many of this fit over there until here. So if I call this P, and this is Q, and this is point O, so we want to know how many of this fit there. So we can use proportion, that means the whole round. So let's see, length of the arc is proportional to angle at the center. So we use this idea that, so if it is the length of the arc, that's S, so proportional meaning length of the arc, so this arc is length is arc, the angle at the central angle is theta, and if I take the whole around, the length of the whole around is the circumference, which is 2 pi r, so that's 2 pi r. So I'm using the left side is only for this arc. This is the left. So I'm using this as the main part. So this corresponds to this theta, but the whole around is 2 pi r, length of the arc, because of this. And the whole around is when you rotate, we've seen that the angle that is in radians is 2 pi r. So that's 2 pi. So this is 2 pi. And can you see this 2 pi crosses out? And you get S over theta equals R multiply theta both sides. And you can see length of the arc is R theta. It is also same as theta times R, just to show that this theta is a real number. So this is a real number because you are just asking how many radii fit in the arc. That's what that means. So this theta is like a number. If I have this like 3, 5, maybe from here to here is 5, and then there is a little more. So we want to know how many fit there. So that's why S equal RT, or theta is also, if you divide by R, you get S over R. So this and this can be used. So you can, if they give you the length of the arc and the radius, you can find the angle at the center. Or if you are given what is the angle and the radius, you can find. So this is what I wanted to show. The next video that I will make is how do we find area of the sector. So wait for the next class. We'll see how to find. So the goal is not just doing a lot of problem, but understanding the concept, how it works. So why it is length of the arc is like this. We will see the area of the sector is why it is r squared theta divided by 2. We'll also see why the linear velocity, linear speed is the distance. So we'll see linear speed as s over how much distance divided by time. We'll also see the angular speed, which is the angle going around so these are the things we will see in the next video. I'll try to show and hope that helps. Thank you for watching.